गुड इवनिंग। स्वागत है आप लोगों का अनअकैडमी फ्लक्स चैनल पे। सुरेश VSR, वेलकम बैक टू Electromagnetics पार्ट 3। सो कैन आई हैव योर confirmation if I'm live? Just waiting for your confirmation, students. Am I live? Just indicate in the live chat. Hello. Yeah, I could get it. Yeah, students. Yeah, got it. Vineet Agarwal, hi, how are you? Yeah, just got a slow system. Yeah, right, it's working. So just a second, students, let me just reduce the volume of my live chat. Yeah, so AT Rai, hi, welcome all of you, welcome students. I'm discussing today about the continuation of basic terms and definitions of electromagnetic fields. Yesterday we discussed about divergence and curl, gradient, divergence, curl with its mathematical meaning. Today also we'll continue the discussion by drawing some diagrams, by taking some numerical examples, by looking at some pictorial representation of what divergence is. So before that, I hope you all are ready, students. Mukesh, hi Mukesh, nice always seeing you. So yeah, this is the course going on now, basics of electromagnetics. This will go on until the entire basics are clear. So tomorrow also there will be a class, Monday, Tuesday, Wednesday, Thursday, and of course this 4 days week it will go on for basics until you understand. This week, tomorrow is the last class, so next week it will continue. Another big thing is, of course, this is what I'm telling you, electromagnetic waves. This is going on free if anybody is interested. इसमें 6 classes हो चुके हैं already. ये Unacademy app में चल रही है. 6 classes have been completed for EM waves and this is completely free. Another 5 classes are still pending. I mean, another 5 classes are yet to happen, because we have just finished wave propagation, so we have to finish polarization, power, until reflections and transmissions. So this is also the understanding of electromagnetic waves, complete free course. And other things, mostly ISRO previous year questions, ye bhi ho gaya this month. This also in free category. We are having an revised ISRO session going on, and 22nd we have an exam for ISRO pattern. So that's the series going on now. मेरा topics हो चुके हैं. My EMT, EDC and microwave have been completed. All the previous year questions I have analyzed. So analyzing all the previous year questions. Yeah. Next most happening thing is this. In subscription category, I've started antennas. जो 20th को शुरू हो रही है morning 8:30. Complete antennas from 0 level to the advanced practical antennas. Subscription course है ये. Morning 8:30, because all my evening slots are busy. So morning 8:30 the course will start, and it is to be used, I mean it is for subscription in plus category. So do use my code and subscribe. 20 hours तो मैंने अभी schedule किया, but I think this will go to 20 plus only. Minimum तो अभी मैंने 20 hours schedule किया. If necessary we'll go beyond 20 plus only, because practical antennas for ECE also will cover. GATE के लिए 20 hours काफ़ी है, but beyond GATE when you go, you'll be needing it. So that's where the things are. Anand Tiwari, Shivendra, Shivendra, ISRO exam last year का ही recruitment complete नहीं है. So this year ISRO exam they'll mix up with last year aspirants only. So इस बार ISRO का notification भी नहीं आया, exam को तो कोई पता नहीं है. Last year का interviews का भी पेंडिंग है अभी. सो इसरो एग्जाम वी कैन नॉट एक्सपेक्ट दिस ईयर. एंड शिवेंद्र, नो, अनंत तिवारी, नो अनंत, फुल कोर्स इज ऑलरेडी अवेलेबल, यू कैन वॉच रिकॉर्डिंग. अभी ये जो कोर्स शुरू हो रही है सिर्फ एंटेनास के लिए है. फुल कोर्स चाहिए तो रिकॉर्डिंग इज ऑलवेज अवेलेबल. इग्नाइट बैच में देख लीजिए तो बेस्ट है. इट वेंट ऑन फॉर 100 hours. उसमें भी एंटेनास हो चुका है, बट आई एम अगेन लॉन्चिंग एंटेनास एक्सक्लूसिवली बिकॉज एंटेनास इज टफ. सो अभी जो कोर्स हैं ये तो सिर्फ एंटेनास के लिए हैं, बट फुल कोर्स इज ऑल्सो अवेलेबल. यू हैव टू वॉच रिकॉर्डिंग, दैट्स ऑल. AT राय, Anant Tiwari, you can just message me on my WhatsApp number. I'll send you the link. आपको मैं लिंक भेज सकता हूँ. You can just watch. I'll send you the WhatsApp number. और you search for Ignite batch. Ignite batch जो April 25th का शुरू हुआ. सुरेश VSR और Ignite batch April 25th का शुरू. उसमें full course हैं. You will get the complete content in it. ठीक है? 80 Rai. It is morning 8:30. Yeah, it is for 12 days. लगभग 12 days तक schedule किया मैंने भी. So it's almost for 12 days and morning 8:30 every day. Every day it is there. Yeah, Amal, Ajay, hi, good evening, hi, nice seeing you. VT, hi VT, nice seeing you. So all my regular students joining slowly, they are joining. तो इतने में धीरे धीरे ads भी हो गया. But one vital thing I want to tell you this day today, students, जितने भी लोग हैं, test series, please don't purchase anywhere test series because we have completely lot of free test series. मतलब Unacademy has got so many series of test series. This is my contact number, students. Anytime you can WhatsApp me or my Telegram channel you can follow. So आपको कोई भी doubts हैं तो you can always follow me, timings and all. Yeah, this is my WhatsApp number. Okay. 80 Rai, if you take for 1 month subscription के साथ almost one subject you can completely finish off. 1 month if you take subscription you can finish off one subject. If you are sitting for 4-5 hours a day, मतलब थोड़ी hectic हैं, तो 2 subjects अभी complete कर सकते हैं. 2 crucial subjects, but 1 month generally, ideally 1 subject you can complete. क्योंकि हम लोग live पढ़ाते हैं तो it goes on for 2 months. Live में ना doubts के साथ, उसके साथ it takes 2 months. After a lot of interaction, lot of doubts, बहुत सारे doubts आते हैं, बहुत activeness होती है. So otherwise when you are watching it yourself without doubts and all, you can finish in 1 month. Yes, you can surely finish off, right? Yeah, 80 Rai, surely you can subscribe. Surely you can subscribe with my code, and for any details, you please WhatsApp me. You can contact me on this WhatsApp. I'll send you the links. I'll send you the details and everything for subscription. Anything you can always feel free to ask me. कोई भी doubt हो तो भी. Generally doubts के लिए what we are doing is we are asking students to come live in the special classes. Actually क्या हो रही है ना, students expect doubts to be clarified after the batch. तो हमने क्या किया, since there are a lot of special classes happening, we are calling them live so that we can talk live and clarify it. आप WhatsApp में मेरे को doubt भेज दो तो भी I'll call you live. If it is a big doubt, otherwise it's small, I'll clarify it there. So as per ऐसा होती है schedule generally for doubts. Okay. Yeah, sure. So you can just meet me in WhatsApp and ask your doubts. हाँ, ये बोल रहा था कि टेस्ट सीरीज के बारे में बोल रहा था ना. Lot of free test series are there, students. Lot of free test series. Get Set Go. Oh, you know we had Get Set Go. Test Your Basics. ISRO series भी हैं. So इतने सारे test series हैं. You don't have to for any branch. UPL हैं. मेरा खुद का Super 30 test series था. 3,300 students have registered in ECE for Super 30 test series on Suresh VSR. 3,300 students for free test series. Awesome response, students. That was in August, September. All the 8 subjects have conducted. So ऐसा ढेर सारे free test series हैं. वो सब अभी भी accessible हैं. So don't purchase any test series again anywhere here and there, because all of them are accessible. ये देखिए Gate of Thorns, कभी Unacademy Gate Challenge. ये मेरा खुद का Super 30 test series. And this is of course most expected questions. ये अभी चल रही है. टेस्ट 14 नवंबर को, 21 को, 28 नवंबर को. सो दैट्स वेयर मोस्ट एक्सपेक्टेड क्वेश्चन. ऐसा काफ़ी टेस्ट सीरीज हैं. डिफरेंट एजुकेटर्स टेस्ट सीरीज आर देयर. सो गिवन ऑल दिस टेस्ट सीरीज, यू आर फ्री टू एक्सेस देम एनी टाइम. सो डोंट परचेस टेस्ट सीरीज एनीवेयर हियर एंड देयर. इज दैट क्लियर, स्टूडेंट्स? चलिए, सो शैल वी स्टार्ट टुडेज क्लास. आज की क्लास शुरू करें. आई वॉन्ट टू जस्ट डिस्कस टुडेज क्लास by once again teaching what is divergence, curl and gradient. एक बार divergence, curl and gradient देखते हैं. Especially Vikas Shaw, he was very active about gradient. And yesterday being very basic, I said just relax. But today I think diagrammatically I can show you what is gradient, what is divergence and what is curl. Look at it. Vikas Shaw, are you there? Oh, thank you, Sriram. Nice to see you, Sriram. Sriram, nice to see you. You share my name. My name is also Suresh Sriram Krishna in fact. So nice to see you. Bikash, are you there here? Bikash, एक बार देखिए. I want to discuss, students, how you understand gradient concept through diagram. उसके बाद divergence का diagram देखते हैं, curl का भी diagram देखते हैं. So understanding divergence, gradient, curl with diagram, let's take the simplest example. सबसे simple example लेते हैं temperature का. So consider a scalar function which is temperature, heat or temperature on the map of the world. मतलब globe पे temperature on the earth. मैप इसलिए बोल रहा हूं कि आई वॉन्ट टू स्टडी द टेम्परेचर इन 2 डायमेंशंस. कौन से 2 डायमेंशंस में? एक्स डायमेंशन फ्रॉम ईस्ट टू वेस्ट एंड वाई डायमेंशन ऑफ नॉर्थ टू साउथ. सो अर्थ तो 3D है, बट आई वॉन्ट टू स्टडी द टेम्परेचर ऑन द मैप विच इज 2D बाई ट्रैवलिंग नॉर्थ टू साउथ एंड ईस्ट टू वेस्ट. इसका ग्रेडियंट कैसा होगा देखते हैं, ये स्केलर फंक्शन कैसा होगा देखते हैं. रेडी स्टूडेंट्स? विकास शाह, ओ यू आर देयर विकास, नाइस टू सी यू. इनफैक्ट ये मैंने आप ही के लिए स्पेशली डिजाइन किया, ये ग्रेडियंट का स्पेशली एग्जांपल. अदरवाइज मैं डाइवर्जेंस एंड कर्ल के पीछे था. आई वाज एक्चुअली बिहाइंड डाइवर्जेंस एंड कर्ल ओनली टुडे, बट आई थॉट ओके लेट्स कंसीडर ग्रेडियंट आल्सो एज एन केस स्टडी. ध्यान से देखो विकास शाह, टेम्परेचर जैसे स्केलर फंक्शन का मैं ग्रेडियंट पढ़ना चाहता हूं, टेम्परेचर का वेरिएशंस पढ़ना चाहता हूं, टेम्परेचर ग्लोब पे, अर्थ पे, 2D में. सो फॉर दैट इफ यू लुक एट द मैप ऑफ द वर्ल्ड, दिस इज USA, अमेरिका, नॉर्थ अमेरिका, दिस इज साउथ अमेरिका, यूरोप, अफ्रीका, एशिया एंड ऑफ कोर्स ऑस्ट्रेलिया. ठीक है? दिस इज समवेयर इक्वेटर. ये 0 डिग्रीज वाली इक्वेटर है. सो हाउ इज द टेम्परेचर वेरी? यहां पे सबसे ज्यादा टेम्परेचर होती है इक्वेटर पे. सो टेम्परेचर ऑलवेज ऑन एन एवरेज एट द इक्वेटर, लेट्स से इट इज 40 डिग्रीज, लगभग 40 डिग्रीज हैं. और वो इक्वेटर पे अफ्रीका पे हो, अमेज़न फॉरेस्ट पे हो, इंडिया पे हो, साउथ श्रीलंका पे हो, हर जगह 40 डिग्रीज हैं. सो आई कैन शो द स्केलर मैग्नीट्यूड एट डिफरेंट प्लेसेस. स्केलर मैग्नीट्यूड दिखा रहा हूं मैं. थोड़ी ऊपर जाइए नॉर्थ पे, जैसे इंडिया वाली कंट्री पे, average is almost 30 degrees. At Tropic of Cancer लगभग 30 डिग्रीज हैं. उससे थोड़ी ऊपर जाइए नॉर्थ की ओर तो थोड़ी और बेहतर हैं, बट 30 डिग्रीज. जैसे जैसे यूरोपियन कंट्रीज में जाएंगे टेम्परेचर ड्रॉप्स, जहां पे एवरेज हो जाती है लगभग 25. पूरा नॉर्थ पोल पे चले जाइए तो एवरेज इज अराउंड 5 डिग्रीज. ये हो गया टेम्परेचर वेरिएशंस. वैसे हम साउथ में भी कर सकते हैं, इक्वेटर के नीचे भी, बट इक्वेटर के नीचे काफी कंट्रीज नहीं है, वेरी फ्यू कंट्रीज लाइक ऑस्ट्रेलिया, साउथ अफ्रीका, दैट्स ऑल. तो नॉर्थ की ओर काफी हैं. स्टूडेंट्स, नाउ टेल मी, हाउ इज योर टेम्परेचर फंक्शन T varying with? The temperature function is varying with x and y 2-dimensionally, with major changes being only with y. y के साथ ही चेंज हो रही है. सो टेम्परेचर फंक्शन इज नॉट चेंजिंग विथ x, क्योंकि हॉरिजॉन्टली जाइए ना ईस्ट टू वेस्ट, ज्यादा चेंज नहीं होती है. नॉर्थ में जाइए या साउथ में जाइए तभी चेंज होती है. y के साथ ही चेंज हो रही है, x के साथ चेंज नहीं हो रही है. तो व्हाट इज द ग्रेडियंट ऑफ दिस फंक्शन गोइंग टू बी? इस फंक्शन का ग्रेडियंट कैसा होगा? द ग्रेडियंट ऑफ दिस फंक्शन इज गोइंग टू बी perfectly with y direction only. So gradient of t लेने से you will get ay. So gradient will tell you in what direction the function is changing. और यहां पे gradient पक्का अपवर्ड दिखाएगा ऐसा, क्योंकि फंक्शन यूं चेंज हो रही है, यूं नहीं. So what is gradient is, it will tell you the rate of change of temperature along with the direction of change. हाँ, प्लस और माइनस ए वाई जो भी है. साउथ का हमने साउथ कंसिडर नहीं किया ना, प्लस और माइनस राई एनीथिंग प्लस और माइनस. आई जस्ट टुक वाई वेरिएबल ना, सो वाई. सो द कॉमन सेंस इज दिस स्टूडेंट्स, कि टेम्परेचर का चेंज x के साथ नहीं है, तो ग्रेडियंट डायरेक्शन इज नॉट इन x, क्योंकि टेम्परेचर डजंट चेंज एज यू गो फ्रॉम ईस्ट टू वेस्ट, इट चेंजेस ओनली व्हेन यू गो फ्रॉम नॉर्थ एंड साउथ. सो y डायरेक्शन में है ग्रेडियंट का डायरेक्शन. आई टुक ए 1D एग्जाम्पल बिकॉज टेक ए 2D एग्जाम्पल, 3D एग्जाम्पल, ब्रेक योर हेड विद दैट एग्जाम्पल. इससे और कुछ कॉम्प्लिकेशंस नहीं है. सर मैं टेंसर लेता हूं उसके बाद, नो डोंट टू मच 3D तक काफी है. सो 1D एग्जांपल जैसे टेम्परेचर, इफ यू अंडरस्टैंड वोल्टेज, पोटेंशियल ग्रेडियंट, मैं पढ़ाऊंगा ना बाद में. आई होप यू गॉट द पॉइंट स्टूडेंट्स. एनी डाउट्स एनीबडी? आर यू क्लियर विद ग्रेडियंट? ग्रेडियंट डजंट टेल यू एनीथिंग बियॉन्ड द स्केलर फंक्शन मैन. आपकी स्केलर अगर y में चेंज हो रही है तो ग्रेडियंट का डायरेक्शन y में होगा. रेट ऑफ चेंज फंक्शन में ही दिखेगा. ग्रेडियंट करने के बाद एक्स्ट्रा कुछ नहीं मिलेगा आपको, डायरेक्शन मिलेगा बस. योर फंक्शन टेल्स मैन हाउ योर फंक्शन इज वेरिंग. आपकी फंक्शन खुद बताती है कि कैसे चेंज हो रही है फंक्शन. उस पर डिफरेंशिएशन करके बस रेट ऑफ चेंज पता चलेगा बस. एनी डाउट्स एनीबडी स्टूडेंट्स? Right, because I remember you are there for waveguides. I know you are a very sincere student, and I remember you are there in waveguides. You also said you are preparing yourself, so I can understand it. But एक sequence में जाइए ना, तो you'll really enjoy it. Now enjoy divergence and curl now, जो सबसे critical point है. That is, look at students, gradients diagram you have seen. Look at now what is divergence diagram. That is, if you have a vector and you want to understand divergence, through a diagram, have a look at it once. ध्यान से देखिए. Look at a diagram, look at a vector. Look at a vector like light from a bulb. एक बल्ब है, यहां से आते हुए लाइट है. The light from the bulb has got a intensity. उसकी जो स्ट्रेंथ है 5 watts पावर इक्विवेलेंट है उसका. वो 10 watt बल्ब होगा शायद, या 100 watt बल्ब होगा. तो at some point it is 5 watts. थोड़ी दूर जाइए तो इट इज बिकमिंग 3 watts, फिर 1 watt. सिमिलरली यहां पे भी 5 watt, 5 watt, इधर 3 watts, ऐसा चेंज हो रही है. सो द वेक्टर हियर इज लाइट एंड द स्ट्रेंथ ऑफ द लाइट. वेक्टर है यहां पे लाइट और उसकी स्ट्रेंथ. सच दैट द लाइट इज गोइंग लाइक दिस. लाइट इज गोइंग लाइक दिस. अब ध्यान से देखिए, इन व्हाट डायरेक्शन द लाइट इज गोइंग. जिस ओर लाइट आगे बढ़ रही है उसी ओर चेंज भी है उसका, कमजोर भी हो रही है. That's exactly what divergence is. So divergence is a measure of rate of change in the direction of the vector. So light एक ऐसी vector है, light is a vector which is function of x, वो कमजोर हो रही है, चेंज हो रही है x के साथ, और उसका डायरेक्शन भी x में. Light is a function of x directed in x या y, जो भी है, डायमेंशन जो भी ले लीजिए. Otherwise again, Rai will ask me, sir, why not x and z? X हो, y हो, z हो, one day में बात करते हैं. So we say the vector has got divergence. अब कर्ल कब होती है? जब उसकी चेंज ऐसे वेरिएबल के साथ हैं जो उसको परपेंडिकुलर हैं. देन कर्ल विल एग्जिस्ट. कर्ल का डायग्राम भी देखते हैं. लेट्स अंडरस्टैंड द डायग्राम फॉर कर्ल. टेक 10 seconds and tell me, did you understand divergence diagrammatic explanation? डाइवर्जेंस का डायग्रामेटिक एक्सप्लेनेशन समझ में आया कि नहीं आया, एक बार बताइए. थैंक यू शिव प्रसाद, थैंक यू. टेक 10 seconds and if you got doubts ask me. एक्चुअली एजुकेशन के लिए इंटरनेट इज स्टिल नॉट कंसिडर्ड टू बी वेरी गुड ऑप्शन. एंटरटेनमेंट के लिए इंटरनेट अच्छा है, यूट्यूब वीडियोस देखने के लिए, बट वी वांट टू टेक serious teaching also to YouTube level. Yeah, last 20 years I've been teaching, but in YouTube last 11 months I'm teaching. I never came in YouTube or Facebooks and all in the last 11 months. I was in a very professional institute, totally offline. So we are now trying to get it to much wider range of, wider level of reach. So that's what we are trying, that's all for. Yeah, sure, Divya. Divya, I think yesterday's class you should have seen. That's one of the things in yesterday's class where I taught you some maths like this. That's one thing. But maths apart, Divya, the physical meaning of divergence is you find out the rate of change of a vector by going in the direction of the vector. So if you are having a vector like light which is traveling in x direction, you find out how is it changing with x. That means you do the dou by dou x in the direction of x. This is what we say divergence. So divergence is physically a measure of finding out the rate of change by moving in the vector direction. How does light travel? Light travels away from the bulb. So you move away from the bulb and find the intensity of light. Then is when we say we are finding divergence. Suppose light is traveling like this. You are moving like this and finding the rate of change. Is there any rate of change? No. So light direction is like this. And if you move like this and find the rate of change, that is not divergence. Divergence is moving along the direction of the vector and finding the rate of change, not by moving perpendicular to it. Don't go perpendicular to the movement of light, go parallel to the movement of light. That's what exactly I mean here. Pavan Kumar, I hope you got it. Just look at the same explanation, Pavan Kumar and Divya, after curl. I'll get back if necessary. I'll just get back to this same discussion after curl. Just look at it once again. If you move from here to consider curl and the diagrammatic understanding of what is curl, look at it. There is a light, there is a bulb, and its intensity is 5 watts here, 5 watts here, 5 watts here, 5 watts, 5 watts. Its intensity is 3 watts, 2 watts, 1 watt, So on here also 3 watts and so on. The light here is traveling in x direction, and if you are going to find the rate of change like this by going in y direction, you are finding dou y for a function which is in x. This is curl operation. For x directed function, x directed magnitude, you are finding out the derivative with y. Or you can do for the same x directed function, derivative with z. This is curl operation. By moving perpendicular to the direction of the vector direction is like this. You are moving perpendicular like this and finding the derivative. That is sin theta derivative. This is curl. I hope you got the point, students. So where is this curl operation important? Divergence is important for light, electric field, all outflowing phenomenon. Where is curl important? Just have a look at it. When you want to understand where curl is important, take for example a fan. A fan is revolving, so is air revolving here. So that the air is revolving here at a speed of 10 kilometers per hour. Here also air is revolving at 5 kilometers per hour far away. Here also air is revolving at 2 kilometers per hour. So this is the direction of air. But how is the air velocity decreasing? How is the air velocity decreasing? The air velocity is decreasing not when you go in its direction. It is decreasing when you go like this, perpendicular to its direction. Don't go in its direction, go perpendicular to it. So here the change is occurring with y when the function's direction is in x. Their curl is important. Circulatory phenomenons have curl, cross product, sin theta dependent. Take 10 seconds time. If you followed, well and good. Otherwise, we'll again take Gauss law and Ampere's law as examples. It's not that it's over today. If you don't follow, you won't understand it. It's not like that. The basics of electromagnetic fields are based on it. Why we take sin theta derivatives and cos theta derivatives are important. Take 10 seconds gap. Ask me some doubts. Divya, Pawan Kumar, I hope you understood. And of course, Vineet, VT, my favorite students, always I know you'll understand it. Take 10 seconds doubts. Any questions? The continuation of yesterday's maths is what I've done. I did not do anything new. I continued yesterday's mathematics of cos theta and sin theta's importance. Just taking a diagram, that's all. Thank you, Pawan. Thank you. Fine. You all understood it. Right. So that's where the yesterday's mathematics is clear. Let's come to today's first question then. Today's first question is, this is the first question for today. Oh, sorry. Yeah. What is the difference between intensity and density? What is the difference between intensity and density? why do we have two measures of field strength? Why do we have two measures of field strength? What is the difference between intensity and density? You can tell your answers creatively in the live chat. I want to see your answers. Of course, my favorite students, Mukesh, always ready to answer, VT. I want this series to be as lively and as good as that waveguide series I took in September. September waveguide series was the ultimate. I mean, I enjoyed maximum, though it was early morning, 8 o'clock. It was ultimate series. You gave me really good energy. That's why I took this series now again. So if you are lively and answering, it's some sort of an ease for us to teach, because we can't see you. You can see me, but I can't see you. So when you give me something in the live chat, answering something, I just get some feel that okay, fine, people are understanding it. So tell me, students, what is the difference between intensity and density? Simple logic, students, very simple logic. When field is spread in three-dimensional space, when energy is spread in three-dimensional space, the strength of the field can be measured as d by dl of the cos or the force, d by dl of the force or the cos, or it can be done as d by ds. That is the difference. In simple words, students, I want you to grasp a very simple point. See, you just understand what is the difference between force and pressure. What is the difference between population and population density? You will automatically understand what is intensity and density. I will give you a 1 kg of cotton and ask you to put your hands or put cotton in your hands. 1 kg cotton. It's quite easy. You can put it. I'll ask you to put 1 kg stone in your hands, which is a bit heavy. है तो 1 kg लेकिन थोड़ी मुश्किल है stone उठाना, a bit tough. I'll ask you to put a 1 kg needle in your hand like this. 1 kg needle in the hand. Are you getting this point, students, all of you? 1 kg cotton, you can lift it, put it in your hand. 1 kg stone, you can put it. 1 kg needle, it will pinch you. Why? Because the pressure produced by the 1 kg or the 1 Newton of force is heavy for the needle, because pressure is force acting on that small area. So when that force is acting on a small area, it produces enormous pressure. Similarly, when the field is a force which is producing its effect over a short length, and if you find the strength by dividing by the length, this is called as intensity. So intensity is the idea of the strength of the field by taking a per unit length analysis d by dl. I hope you are all following this, students. So field strength expressed as per unit length, like for example, voltage causes electric field, then we say electric field is volts per unit length. The effect produced by voltage over that free space length between the capacitor plates. So between the capacitor plates, the voltage will produce an volt per meter electric field intensity. This is intensity. What is density then? Sometimes you have to divide that cos of the electric field or the charge or the cos of the field by unit area. That is also a measure of the strength. Like pressure is not per unit length, pressure is force per unit area. Similarly, in electric fields, sometimes we have to divide with area, sometimes with length. This is called as density. So students, intensity is the word that we use when the three-dimensional effects are understood by dividing a length over one line, effects over a length. Instead, if you are finding out the strengths over an area, that is what is called as density. If you look at electric fields and magnetic fields, if you look at electromagnetic fields, E bar is a symbol that we use for intensity in electric fields. E bar intensity, which is volts, charge, voltage produced, voltage is producing this field, so it's volts per meter. There is something also called as D bar, which is called as density, and what produces electric field? Charge, coulombs, coulombs per meter square. I hope you are following this, students. Field produces a force and stress and pressure. Field produces force, stress, pressure. That stress, when expressed as per unit length or per unit area, is intensity and density. What about in magnetic fields? When it comes to magnetic fields, it is called as H intensity, which is ampere per meter, and density equivalent is B Weber per meter square. Any doubts, anybody, students? Are you following? Feel free to ask me questions. Any doubts? Oh, good. Just skipped your live chat. Just seen your live chat. Oh, it's really great. Yeah. Oh, you're all right, Mukesh. Really good. I just skipped it. I was so busy, Itna involved ho gaya I forgot seeing your live chat. Yeah, I could see your answers. They're all right. Ajita was talking about population density. It's all right. Fine. Good. I hope you got the point. Now, if you are clear with this, students, can I go to the next point? The next point is, what is the importance of permittivity and permeability? What is the importance of permittivity and permeability is a very crucial word now. I think let's have a discussion about this once. Because if you're all students understanding permittivity and permeability it is just nothing but ability to permit field. So whether you call it as permittivity in electric fields or whether you call it as permeability in magnetic fields, they both represents the ability of the medium to allow that field or energy it represents how much of ability or ability or permittivity that medium has got to allow this field. Like we say conductor has got conductivity, means it is the ability to allow current, ability to allow humans in water, because we can walk in water. So water will permit humans to go through it. In air we can go through. But can you go through a wall? Wall doesn't have permittivity for humans. Curtain, yeah, usse ja sakte hain. Walls, no, you can't. Water, yes, you can. Oil, no, it's tough. Oil mein theek hai, you can go, but still. So for that respective energy, the ability of the medium to permit is called as permittivity and permeability. The interesting point for the student to understand is electric field permittivity epsilon has just nothing but the units of capacitance, because capacity is the ability to hold charge, capacitance is the ability to hold electric field. कैपेसिटर के प्लेट्स के बीच में इलेक्ट्रिक फील्ड होती है, कैपेसिटर प्लेट्स have got electric field. So therefore epsilon has got the same units as capacitance. So that capacitance is farads, epsilon is of course farad per meter, because capacitance is epsilon A by D. Epsilon A by D. If you watch out similarly mu, ability to allow magnetic field, it has got the same units as inductance. Inductance is the ability to hold magnetic field. Henry, so that mu has the units of Henry per meter. I hope you're getting the point, students. So therefore ability to allow voltage and current, ability to hold voltage and current becomes ability to allow electromagnetic fields. Now there is some reason, students, why I remembered this here. यहाँ पे कुछ वजह है that I have remembered this. There is some link to what I taught now. The link is the density in a medium or intensity in a medium, both measure the field strength. They should be proportional to each other. So whether you call it as density measure or intensity measure, whether it is coulomb per meter square or whether it is volts per meter, they should have the same relationship. They should have a linear relationship. That is what is permittivity's importance is. The D is epsilon E. So the density and intensity relationship depends on the medium permittivity, medium's properties. How much of intensity or density measure is there purely depends on the medium. If it is high, allowing ability is high. Absolutely, Mukesh, yeah. If epsilon is high, its holding ability is large. You get a stronger field, you get a much denser field. That's right, that's right. I hope you are understanding this. Divya, but you should notice a very small point here, that almost last 40 minutes I've been struggling to 30 minutes I'm struggling to teach this. But just look at how you learn this in networks. A network theory teacher simply says that Q is proportional to V, and you all say accept it. Yes, right, he's right. Sir, because charge is proportional to voltage. When you give charge, you will get voltage, or when you give voltage, you charge up your cell phone. You plug it, you charge up. So charge and voltage are same. Then suddenly he says Q is equal to CV, and still you accept it. and still you accept it. Yes, that coulombs is nothing but farad into volts is everybody knows. Then what is your problem when I say volt per meter into farad per meter is coulomb per meter square? If you like your network theory teacher, start liking your field theory teacher, man. Networks में Q equal to CV है, so field theory has got D equal to epsilon E. So voltage, current, charge, all network theory terms I also teach, but totally in 3D space. Totally in 3D space. So that's where the common sense is, students. That when it is networks, Q equal to CV becomes D equal to epsilon E. If we continue the discussion, students, here, there is something more important. Similarly, B is proportional to H. Density and intensity have to be proportional. The proportionality constant is mu into H. So that Webers per meter square is always Henry per meter into ampere per meter. Quite logical, man. Magnetic flux produced depends on the current. Network theory. Current will give you magnetic field, current produces magnetic flux. Wow, super. Yeah, network theory. That magnetic flux produced depends on the inductance of the coil, shape of the coil, shape of the geometry. So that Webers is always Henry into ampere. Network theory में denominators नहीं है. Weber is always Henry into ampere. I hope you are getting the point, students. Any questions, anybody? Wow. 80 Rai, you worked as a microwave expert. That's great, actually. Microwave, in fact, microwave is the father of EMT. No, grandfather of EMT. It's much tougher than EMT. And really nice that you're all enjoying it, students. Microwave also I taught for ISRO batches last year. This year I have not taught microwave because ISRO still is yet to notify. But once notification comes, or if necessary, I'll certainly teach microwave. But only when you're good at EMT, you'll understand it. I want to wind up today's class, students. I want to wind up today's class with one last point, because I have to teach tomorrow's class what is Gauss law, what is Coulomb's law, what is what is Ampere's law, and what is Lorentz law. So to come to actually field theory level and standards of field theory, I want to wind up the discussion with a very small hint and note. Maybe I can teach this tomorrow also. Nothing, it's not really for today. Tomorrow also I can learn it. But the point to understand is this: whenever there is a cause of a field, whenever there is a cause of a field like charge, current, earth, bulb, any cause of a field, a satellite, a cell phone tower, all these are examples of causes of fields. This cause will always have the strength of the field expressed in two ways. Whenever there is a cause of the field, the strength of the field can be expressed in two ways. Can you tell me what are the two ways? Can you tell me what are the two ways? I'll just wait in the live chat once. Just tell me in the live chat, what are the two ways of understanding the strength of the field? What are the two ways of understanding the strength of the field? Waiting for you. Very interesting point, very interesting point. Pavan, no, Pavan. Even if it is electric field, there are two ways. Now, what are the two ways? Only in electric fields. No who is this name? Electromagnetic fields. Beautiful. ये electromagnetic fields नाम कौन है? दिल जीत लिया मेरा. Electromagnetic fields आपका नाम है तो आई दिल जीत लिया आपने. Superb. Wow, what a name really. Intensity and density, beautiful. Ganesh, Rajkumar, Vinit, Anand, VT, yes. Students, the two ways are intensity and density. Very good. But, ध्यान से सुनिए. One is expressing in terms of the cause itself. That if there is Q coulombs, the strength is Q coulombs per meter square. If you give 220 volts to your cell phone tower, you will get millivolts in your cell phone. If you give 440 volts to the satellite, your receiving satellite will get 2 millivolts. That's Mukesh. Mukesh is now coming into the point. So, cause of the field can be used to find the strength of the field. The second way is expressing the strength as a force, because every field will produce a force again. Energy produces force. Energy is work. Work is force into displacement. So every field is a form of energy and every field will produce a force. So आप कॉस्ट में एक्सप्रेस करो या फोर्स में. That's what is Newton per coulomb. E bar intensity, D bar density. So strength can be expressed as intensity and density. Sometimes intensity is for force, density is for cause. This is what is Gauss law. This is Coulomb's law. ये Coulomb's law होती है, ये Gauss law है. Similarly, Lorentz law in magnetic fields and Ampere's law in magnetic fields, they're equivalents of this. That's Mukesh, students. That's sure, Pavan, sure. Anybody else wants it once again? Don't worry. Just feel free. Internet class hai ye. See, when I was teaching waveguides, rectangular waveguides, September. Randomly, some students used to come in between. Kuch na kuch comment, kuch na kuch puchna. They used to go away like that. Once or twice I told them, students, it's a very serious class, be serious. Don't come just for fun like that. Uske baad koi nahi aaya. Nobody came like that. I was very happy. Then we really got the feel of a live class. That's exactly the way. If you ask such doubts genuinely, like Pavan asked, sir, repeat once, we really get a feel. Like randomly if somebody comes into the class and puts some comments and go, we feel bad. Because at one stage at level we worked, I taught for 400 students in a classroom, live, 400 students. So at that level when we work, we expect a lot of seriousness from you. So interaction also in the same way. So Pavan, very good if you ask me like that. Sure, Anil Kumar, sure, don't worry. See, that's exactly what we expect the seriousness from you also. Once again look at it, students, I'm trying to tell you that whenever there is a field, due to a cause, the field strength can be expressed in two ways. How strong the field is If you have a cos here, how strong it is can be expressed in terms of the cos itself. If I give 400 volts, 440 volts to the tower, cell phone tower, I'll get 4 millivolts at the cell phone. तो ये बोलते हैं 440 volts of cos is giving you 4 millivolts of strength. 440 volts of cos is giving you 4 millivolts of signal strength. So therefore, whenever there is a cos of a field, the strength of the field can be expressed in terms of the cos. Is this point very clear? Pawan, Anil, is this point very clear? When a satellite is given with some cos voltage, the receiving station will also get some voltage. So therefore, students, Rajkumar, yeah, Rajkumar, you're also right, in fact. Yeah, you're expressing the strength in terms of the rate of change. That's also a very good idea, Rajkumar. That's good, really good. Yes, Rajkumar, you're right. Chalo, if you continue the point, students, once again, if you continue the point here, there is something interesting to continue, because this cos, if it is Q coulombs, the strength is Q per unit area. That's what is D bar. This is Gauss law. Tomorrow we'll discuss about it. But this cos Q also will produce a force. The strength is that it will also create a force there. This charge is giving you some induced charge. That is also one measure of strength. Okay, that's also okay. But remember, students, this charge will also produce a force. That's what is E bar Newton per coulombs. So the common sense is this, students. Field is a spread of energy. So therefore, field can be expressed in terms of this cos. Anything around it, इसके आसपास energy जो भी है, you can express it in terms of the cos of the field. But you can also express it as a force. Are you getting this point very clear, students, now? This is the uniqueness of electromagnetic fields. The same continues in magnetic fields also. Maybe in tomorrow's class we'll discuss about it. So if you got any questions, you can ask me. Otherwise we'll wind up. And don't mind if you want me to repeat, I can repeat. I don't mind repeating also. But vital, students, strength of the field is expressed always in terms of the cos of the field and the force produced by the field. How much of force is being produced is also measured. How much of cos you are given is also measured. When I have an 50 watts of antenna power, 50 watts of antenna power, I will get few milliwatts in my receiving antenna because of this, by field, because of the field. So this cos will give you this effect due to the field in between. Any questions, anybody? Any doubts? You can ask me now. Otherwise, see you tomorrow with Gauss law. Tomorrow I will continue the same thing. See, nothing is over in one day. Nothing is over because one basics are completed. Tomorrow again this will repeat. Gauss law, Coulomb's law, Lorentz law, Ampere's law. It will repeat tomorrow also. So I will stay for 20-30 seconds. If you got doubts, ask me. Thank you, Mukesh. Thank you. Thank you, Mukesh, always for being with me. Mukesh, always my favorite student, always with me. So these are all the test series students. I was talking about a lot of test series. ये सब free हैं. And this is my contact details. Anytime you can be in contact. Rajkumar, cos and force, they are related by epsilon. That is what I taught you now, permittivity. How much of charge will produce how much of force depends on the medium. You have so much of charge that will produce so much of force, it depends on the medium. So Rajkumar, cause and force will always be depending on the medium. Divya, if this is your first class, you attend 2 more classes. Just before to it, just watch them once. Divya will really enjoy the first 2 classes also. It will go in a sequence like this. This is for beginners, na? So do enjoy my first 2 classes also. Then you'll really like it. Chalo. Thank you students. Good night. See you. Sure, Anil Kumar, you can always call me. You can just put me a message. Put a WhatsApp message. If necessary, you can call me because the phone won't be with me. Only the WhatsApp will be with me. So just put me a message. If necessary, you can call me. Because for any call, you have to take a WhatsApp appointment first. So take a WhatsApp appointment, then you can always call me. Okay? So you can surely. Good night, Bikasha. Rai. See, Rai, you got 2 options. Since you're microwave expert, you can directly come for antennas. Right? That's one thing. Because you're a microwave expert, 80 Rai. Second thing is, if you feel not very comfortable, if you're not comfortable with antennas, at least learn electromagnetic waves and come. Basics of electromagnetic waves, sufficient. But anyhow, when you're taking subscription, you can watch entire Ignite batch, because 1 subscription for any course. Unacademy has got 1 single subscription for all courses, all teachers, all exams. Just 1 subscription. So once you're coming for antennas, if you're not comfortable, you watch other courses also. But otherwise, I think you can join it. Got it? Any other doubts? Oh, good. If you've done my classroom course, I think you'll be very comfortable with the antennas. You'll be very, very comfortable. Hi, Shishir Srivastava. 3rd class, just seeing you today only, Shishir. Yeah. I'm sure you can follow. You're working in Ericsson, I understand, right? See you then, students. Bye. Good night. Any further queries? Put it to WhatsApp. Bye.